October 14th, 1974. Earl Hutchins signed a release form at a county auction lot outside API, Pennsylvania, and walked away from a 1948 Case LA tractor for $11. He did not look back at it. The machine sat where it was left, in a fence row at the edge of a soybean field, for the next 49 years. Let me tell you about the Case LA. In 1948, it was not a small tractor. It carried a four-cylinder engine displacing 284 cubic inches, putting out close to 45 horsepower at the belt. For a Pennsylvania dairy farm, that was enough to run a baler, a silo filler, and a feed grinder without strain. It was built heavy, with cast iron where lighter machines used stamped steel. Farmers who bought one expected to keep it for 30 years. Most did. The Case LA was not glamorous. It was not the kind of machine that ended up in museums or parades. It was a working tractor built for fields that did not care what it looked like by the end of the day. The company had been building farm equipment since 1842, and by 1948, they had refined the LA into something that asked very little and delivered a great deal. The throttle was simple. The controls were direct. A man who had never seen one before could figure out most of it in an afternoon. That was part of what made it worth keeping, and part of what made it worth walking away from when something newer came along. By 1974, the Case LA on that farm had not run in 6 years. The Magneto was dead. 2 of the 4 tires had rotted off their rims. Field mice had built 3 nests inside the air cleaner housing. The farm itself was being sold off in pieces. The dairy herd gone a year before. The land split between 2 larger operations moving into the county with bigger equipment and longer credit lines. The tractor was not worth moving. It was not worth fixing. The parts to resurrect it would have cost more than a newer used machine, and there was no one left on the property who had the time or the reason to try. It was worth $11 and a place to put it. So that is what it became. $11. A fence row. 49 winters. Steel does not forgive that kind of time without cost. The cast iron rusted from the outside in. The rubber dried and cracked and eventually gave way entirely. The fuel in the tank gummed into a dark varnish that coated every passage in the carburetor. The wiring, what little the tractor had, brittled in the sun and cold until it was no longer wire, so much as a suggestion of wire. The engine sat without oil circulation for so long that the cylinder walls began to oxidize at the surface, and 2 of the 4 pistons bonded themselves to those walls with a rust that did not distinguish between holding and destroying. The machine did not decay dramatically. It decayed the way most things decay, slowly, quietly, without anyone watching. The tractor sat through 49 winters. By the time anyone looked at it again, the question was not whether it could be started. The question was whether there was anything left to start. Rust does not announce itself. It works inward from every exposed surface, patient and thorough, following the grain of the metal, finding every crack and pore and imperfection and making it larger. A tractor left in a fence row for 49 years does not rust the way a nail rusts in a glass of water, uniformly, completely, all at once. It rusts selectively, attacking the thin sections and the interfaces and the places where 2 different metals touched each other and set up a small electrical current that the years turned into corrosion. Some parts of the Case LA were nearly untouched. Others were gone entirely. The question was which was which. In March of 2023, a man named Travis Marsh bought the property where the tractor sat, mostly for the timber rights on the back 40 acres. The Case LA came with the deal, listed on the paperwork as one miscellaneous tractor, non-running. Marsh had restored 2 smaller garden tractors before, a Cub Cadet and an old wheel horse that had belonged to his father. He had never taken on something this size, with this kind of history, in this condition. He spent 4 days just walking around it before he touched a wrench. He photographed every angle. He noted which bolts were seized and which had corroded entirely to nothing. He found the serial number plate still attached to the dash, its numbers faint but legible. He pulled weeds away from the wheels and found the steel rims intact beneath the rotted rubber. He opened the hood and looked at the engine without touching it, the way a doctor looks at something before deciding where to begin. On the 5th day, he picked up a wrench. Before anything else, Marsh needed to know if the engine itself was salvageable. Everything else, the fuel system, the ignition, the wiring, could be replaced or rebuilt around a sound block. But if the block itself was cracked, or the cylinder walls were worn beyond what boring could correct, or the crankshaft had twisted or scored, the rest of the work would have no foundation. The engine had to be assessed first. He pulled the spark plugs, all four, each one crusted with carbon and surface rust, each one requiring a penetrating soak before the wrench would turn them out without risk of breaking the threads. He threaded a compression gauge into the first cylinder and turned the crank by hand, slow, feeling for resistance and listening for the sound of air moving. The gauge read 0. He moved to the second cylinder. Also 0. The third cylinder gave him 40 psi, weak but present, suggesting the rings were worn but the cylinder itself was not entirely lost. The fourth gave nothing. 2 of the 4 cylinders were either rusted solid or had blown rings. The engine was not dead, but it was not whole. A compression reading of 0 can mean several things. It can mean the rings are gone, unable to seal the cylinder long enough to build pressure. It can mean the valves are not seating, open when they should be closed, leaking whatever pressure the piston manages to create. It can mean the cylinder wall itself is so corroded that no ring, new or old, could seal against it. Or it can mean the piston is not moving at all. In 2 of the 4 cylinders on the case LA, Marsh suspected the last one. The pistons had not moved in decades. The rust that had formed between the piston rings and the cylinder walls had effectively welded them in place. If that was true, the engine would need to come apart entirely, block, crankshaft, pistons, all of it exposed and evaluated. Marsh did not know yet what he would find inside. He pulled ahead and looked down into the bores with a flashlight and confirmed what he suspected. 2 pistons, completely seized. Neither one had moved since the Nixon administration. The 2 seized cylinders held pistons that had not moved in decades, and there's only one reliable way to address that: patience and penetrating fluid, applied in that order. Marsh filled each cylinder with a mixture of automatic transmission fluid and acetone in equal parts, a combination that has been used in engine work for generations because the acetone carries the transmission fluid past the rust and into the microscopic gaps between the piston ring and the cylinder wall. He poured the mixture in carefully, enough to fill the space above the piston crown, and left it. He came back the next morning and added more. He did this every day for 11 days without attempting to move anything. On the 12th day, he set a block of hardwood against the piston crown. Not a metal punch, because metal against metal on a seized piston risks damage to the crown, and tapped it with a 3-pound hammer, measured and deliberate. Not a strike, but a transmission of force. The first piston moved a 1/16 of an inch. He added more fluid and came back the next morning. By the end of that afternoon, the piston had traveled the full length of the bore, stiff but moving, the rust that had held it broken into powder and suspended in the fluid. The second piston took 4 more days. With both pistons free, Marsh measured the cylinder walls with a bore gauge, working his way down each cylinder in 3 positions: top, middle, and bottom of the stroke, and in 2 orientations, measuring both the thrust axis and the pin axis to detect oval wear. 2 of the 4 cylinders measured within the tolerance listed in the original case service manual. 2 were not, worn oval rather than round, off by 11 thousandths of an inch in the worst sections. 11 thousandths is not a large number in most contexts. In an engine cylinder, it is enough to prevent any ring from sealing properly, which means oil consumption, poor compression, in an engine that runs badly, if it runs at all. The block would need to be bored oversized, the cylinder walls cut to a new, larger, perfectly round dimension by a machine shop, then honed to the correct surface finish for ring break-in. And that meant new pistons to match the oversized bore. New pistons for a 1948 case LA are not stocked at any parts counter. They are not listed in any current catalog. Marsh began calling salvage yards in 3 states. He made 17 calls over the course of a week. Most yards either had no case equipment at all or had parted machines where the engine components were long gone. 2 yards had LA tractors, but with standard bore pistons that would not fit an oversized block. 1 yard in Western Ohio thought they had something and called back 2 days later to say they did not. On the 17th call, a salvage yard outside Worcester, Ohio, had a parted-out case LA with an intact set of oversized pistons still in their original factory box, never installed. The owner of the yard had bought them in 1981 along with a tractor he had intended to restore and never got around to. The pistons had sat on a shelf in his shop for 42 years, still wrapped in oiled paper, the box sealed. He sold them to Marsh for $60 plus the cost of shipping. When the box arrived, there was a receipt taped to the inside flap. It was dated March 1981. The pistons inside were in perfect condition. While the engine block went out to a machine shop in the next county to be bored and honed, Marsh turned to the ignition system. The case LA used a magneto, a self-contained device that generates its own electrical current through the rotation of a permanent magnet past a wound coil, producing a high-voltage spark at the plug without any battery. In a properly functioning magneto, this happens thousands of times per minute, timed precisely to the engine's rotation so that each spark arrives at its cylinder at exactly the right moment in the compression stroke. This magneto had not produced a spark in decades. Marsh pulled it from the engine and disassembled it on the bench. The points, two small contacts that open and close to interrupt the current and trigger the spark, were corroded shut, their surfaces pitted and oxidized. The condenser, a small capacitor that absorbs the voltage spike when the points open, had failed entirely. A multimeter showed no capacitance remaining. He cleaned the points with a fine-cut file, working until the contact surfaces were flat and clean, then gapped them to 20 thousandths of an inch using a feeler gauge, the specification from the original manual. He sourced a replacement condenser that fit the same housing. He reassembled the magneto and spun it by hand on the bench, holding the high-tension lead close to ground. A blue spark jumped the gap. Sharp, audible, a small crack in the quiet of the shop. The block came back from the machine shop board to the first oversize and honed with a plateau finish, a surface that would seat the new rings quickly without glazing. Marsh began reassembly. New rings fitted to the pistons. Pistons dropped into the bores with a ring compressor. The head cleaned. The valves lapped to their seats. The head gasket replaced with a new one sourced from a specialty supplier in Kansas who stocked nothing but obsolete agricultural engine parts. When he turned his attention to the fuel system, he found what he had been hoping not to find. The gas tank, a pressed steel unit mounted above and behind the engine, had rusted from the inside out. Decades of condensation had collected on the interior walls and worked steadily through the metal. When Marsh shook the tank, the sound it made was not hollow. It was the sound of loose material moving, rust scale, flakes of metal, sediment that had built up layer by layer over 49 years. A handful of it, when he drained and opened the tank, poured out onto his workbench like coarse sand. The carburetor's float bowl held the same. The fuel passages were packed with varnish and scale. Nothing fed to the engine through that system would reach the cylinders in a condition that could be burned. Marsh sealed the tank's outlets with rubber plugs and filled it with a solution of citric acid and water. 3 pounds of citric acid powder dissolved in 5 gallons of warm water. Citric acid is a mild organic acid that reacts with iron oxide, converting it into a water-soluble compound that can be rinsed away without attacking the bare steel beneath the way stronger acids do. It is slow and it requires contact, which is why Marsh rotated the tank by hand every few hours to ensure the solution reached every interior surface. He let it sit for 48 hours on the first pass. When he drained it, the water that came out was the color of weak coffee, carrying dissolved rust in suspension. He rinsed the tank, refilled it with fresh solution, and repeated the process. Then a third time. By the third drain, the water came out nearly clear. When he shone a flashlight through the filler neck, the interior walls showed bare metal with a faint gray patina, the iron phosphate layer left by the citric acid reaction, which provides a degree of corrosion resistance to the freshly cleaned surface. He sealed the interior with a tank liner and turned to the carburetor, which he disassembled completely, soaked in parts cleaner, and rebuilt with a new kit that included fresh gaskets, a new float, and new needle and seat. The tractor's wiring harness, what little of it existed, had not survived 49 years in the open. The rubber insulation had dried and cracked in the sun of the early years, and then frozen and thawed repeatedly through every winter after that, until the point where the wires no longer bent so much as crumbled. When Marsh tried to trace the harness from a magneto to the kill switch, a section of it came apart in his hands. He found a wiring diagram in a service manual accessed through a tractor enthusiast forum. A scanned copy of the original case documentation, uploaded by a collector in Iowa who had spent years assembling a digital archive of obsolete agricultural service literature. Marsh printed the diagram, taped it to the wall of his shop, and built a new harness by hand, cutting each wire to length, crimping each connector himself, wrapping the finished loom in period-correct woven cloth sleeving. The two rotted tires were replaced with a matched set of bias-ply tires sourced from a specialty agricultural tire dealer in Indiana, the only supplier within 400 miles still stocking that size and construction. The steel rims underneath had survived in better condition than anything else on the tractor. Marsh wire brushed them, primed them, and painted them in the correct case flambeau red, matching the color to a paint code cross-reference from the original factory documentation. By the start of the third month, the engine sat back in the frame. The bored and honed block held the new, oversized pistons in their freshly finished cylinders. The rebuilt magneto was timed and mounted. The carburetor was clean and fitted with new internals. The fuel tank was sealed and lined. The new wiring harness ran its correct paths through the frame. The new tires sat on their painted rims. The cooling system had been flushed, the thermostat replaced, and the radiator rod out by a shop that still did that kind of work. Marsh filled the crankcase with fresh oil, 5 quarts, the same viscosity specified in the original manual for temperatures above freezing. He filled the radiator. He primed the fuel system. He checked every connection he had made, every bolt he had torqued, every gap he had set, working through the machine from front to back in the same order every time, the way his father had taught him to approach anything mechanical. Not because the order mattered, but because having an order meant nothing got skipped. He did not attempt to start it that day. He wanted one more night to think through whether he had missed anything. On a Saturday morning in late June, with the barn doors open and the early light coming in flat across the dirt floor, Marsh set the throttle to the start position, opened the fuel shutoff valve, and pulled the starter rope. The Case LA had no electric starter. It was designed to be hand-cranked or rope-started, a system that required a full-body pull to turn the engine over against its compression. The engine turned. It did not catch. Marsh checked the choke position and pulled again. The engine turned freely, which was itself information. No seizing, no binding, the pistons moving through their bores without resistance. But did not fire. He pulled the plugs one more time, found the gap slightly wide on 2 of them. The plugs had moved slightly during handling, and reset them to the correct specification with the feeler gauge. He primed the carburetor by introducing a small amount of fuel directly into the intake throat, enough to ensure the first combustion cycle had something to work with before the fuel delivery system pressurized. He pulled the rope a 3rd time. The engine fired on the 3rd pull. One cylinder caught first, a single combustion event that rolled the engine over into the next cycle, which caught a 2nd cylinder, and then the rhythm found itself within 4 seconds, uneven at first, a stumble that smoothed as the fuel delivery stabilized, and the choke opened, and the oil pressure built through the passages, and the bearings began to float on a film that had not been there in decades. Marsh let it idle. He did not advance the throttle. He stood beside it with his hands at his sides and listened. He was listening for knocking, the deep, rhythmic knock that indicates a bearing spinning without adequate clearance, which would mean the crankshaft journals had worn beyond what the new oil could bridge. There was no knock. The engine idled with the slightly lumpy cadence characteristic of a large displacement, low-compression agricultural engine at low speed. Not a smooth idle, but a consistent one for cylinders firing in their sequence without missing. He checked the oil pressure gauge, original to the tractor and rebuilt during the restoration process. It read 28 psi at idle, within the range specified in the manual for a warm engine at low speed. He placed his hand flat against the block, feeling for the vibration to confirm it was even across all 4 cylinders, that no single cylinder was carrying more than its share. The vibration under his palm was steady, not smooth. This was never a smooth engine, but steady. The engine ran for 20 minutes before he shut it down to check for leaks. There was one detail that Marsh had carried through the entire 3 months without resolving. Not because he had forgotten it, but because the answer required a kind of patience that the mechanical work had not. The serial number on the dash plate, the one he had photographed on the first day, still legible beneath decades of grime, had been submitted to the case collector registry early in the project. The registry maintained a partial archive of production records, assembled over decades by collectors who had cross-referenced dealer ledgers, factory shipping records, and county agricultural registrations from across the country. The response came back during the 3rd month, while the engine was still at the machine shop. The serial number placed the tractor's manufacture date in March of 1948 and matched an entry in a dealer sales ledger from a case implement dealer in Crawford County, Pennsylvania. A sale recorded in the spring of 1948 to a dairy operation 11 miles from the fence row, where the tractor had spent 49 years. It had almost certainly never left the county. It had been built, sold, worked, abandoned, and found again within an 11-mile radius, in the same Pennsylvania soil, through 75 years of history that no one had been keeping track of except the machine itself, rusting quietly in the fence row. The tractor ran for 20 minutes that first morning, idling in the open doorway of the barn so the exhaust could clear, and so Marsh could watch the ground beneath it for oil drips and coolant leaks. There were none. The temperature gauge climbed to its normal operating range and held there. The oil pressure held steady. The engine did not knock, did not miss, did not produce the blue smoke that would indicate oil burning past the rings. Marsh did not raise his hands. He did not call anyone. He stood beside the running tractor with a rag in his hand, the same rag he had been carrying in his back pocket for 3 months, and wiped down a section of the hood that did not need wiping, the way a person does something with their hands when they do not know what else to do with them. The engine made the sound it had been built to make in 1948. It had not made that sound since 1968. Nothing about the moment asked to be noticed or celebrated. The machine was running. The debt that had accumulated over 49 years in a fence row was not erased. Debts like that do not erase, but it was settled. The account was even. The machine had been returned to what it was, and that was enough. It simply was no longer owed anything. The case LA went back to work that fall, brush hogging the same fence row where it had spent 49 years. The saplings that had grown up around its wheels came down first. Marsh worked the tractor slowly along the fence line, the brush hog chewing through decades of overgrowth, the engine pulling steadily without complaint. It was not restored to be admired. It was not painted to concede to nostalgia or displayed to prove a point about what used to be made and is no longer. It was restored to be used, the way it had been built to be used, on the same ground it had always known, by someone who had decided that 3 months and the cost of parts was a fair price to pay a debt nobody else remembered was owed. Earl Hutchins signed it away for $11 in October of 1974, but did not look back. 75 years after it was built, the machine was cutting the same Pennsylvania ground it had always cut, in the hands of someone who had looked at it long enough to see what was still there.